Before we get started, a few introductory comments, and then I'll introduce the first of our three speakers. We're going to hear from our first speaker and then a combined presentation from our next two speakers. As Julia mentioned, one of the roles I serve is as chair or co-chair of NASCIO's Fuels and Integration Committee. Issues we deal with in that committee include electric issues, electric transmission, grid integration issues. We have a natural gas task force, and so the topic of combined heating and power and grid integration of combined heating and power systems certainly falls right within that committee. My day job is managing the Texas State Energy Conservation Office, and here in Texas we are no stranger to CHP. We've had installations throughout the state for many years, most of those originating in some of the larger chemical and refining operations that had very significant thermal needs where CHP was a natural fit. Today, across the state, we have 137 different CHP sites, and the installed capacity of those combined sites is almost 17 gigawatts. Those are spread across, again, many industrial sites, refineries, chemical plants, and also commercial and institutional, many hospitals and critical governmental facilities, as well as education. Many campuses, university campuses, have CHP installations. And in fact, the University of Texas at Austin generates all their power on campus. Their only feed is they've got backup connections to the grid, but they essentially have two gas pipelines that come into campus. They generate electricity, capture the waste heat, use that for thermal, and then they do all their own central cooling as well. The newest entrant, and this is really the topic of today's conversation, is the utilities. And here in Texas, where we have a restructured and competitive electric market, the municipal utilities are those with more activity in combined heating and power. Austin Energy, which is the municipal utility serving the greater city of Austin, has a number of district energy plants with combined heating and power where they're able to take advantage of the thermal energy for certain processes as well as different customer needs while providing a distributed power system utilizing state-of-the-art, very clean-burning natural gas turbines in an urban setting. So with that, I'll end sort of the introductory comments and turn it over to our first speaker, who is Ethan Rogers, and he is the Senior Manager for Industry with the American Council for an Energy Efficient Economy, as we know as ACEEE. He's been there since 2012. Prior to joining ACEEE, Ethan worked at the Purdue University Technical Assistance Program, where he managed an energy efficiency and sustainability training and implementation assistance program. Ethan earned a Bachelor of Science in Chemistry from Eastern Illinois University and an MBA from Butler University. He's a certified energy manager and a U.S. Department of Energy process heating qualified specialist. So Ethan, we'll turn the webinar over to you now.
Okay. Well, thank you very much, Julia and Dub. I appreciate the opportunity to speak here and the nice introduction. Let me confirm that you can hear me okay before I jump into this.
Yep, you sound great.
Okay. Just wanted to make sure the transition there went well. But let's see here, get to my first slide. I wanted to start by just putting out the proposition that we have, and that is that utility ownership of combined heat and power facilities would make sense, that it would bring greater investment into the market for these very efficient facilities, and that by extension it would bring about the multiple benefits that they can provide both to the hosts of those CHP facilities, the industrial, commercial, or institutional hosts, as well as to the system at large and all the other customers that are served by the grid. So what I wanted to do to break that down is first talk about the benefits to utilities, and then talk about some of the barriers that we see to that, and then finish with some actions that could overcome those barriers. So it's fairly high level, but the idea is to kind of frame the discussion and identify the key points. So probably the one issue that makes utility ownership of CHP or any distributed generation asset for that matter intriguing is that they can think and are used to thinking long term. 5, 10, 20-year investment cycles are not unusual to them, which is much different than, let's say, the industrial sector, which might be looking at 2-year paybacks, or the commercial sector, which would be looking at twice that, and the institutional sector twice that again. So they are used to having patient money. They know their distribution systems, and they would know where to put these assets, where these assets could be helpful to them and the system, and where it could be damaging to or complicate the system. And they know which customers they have that might be able to benefit this. So they've got an awful lot of institutional knowledge there that can help direct where those assets might go. Many utilities still have the ability to rate base those assets, which is a fine thing if you can get it. It's, I suspect, not without its controversy, but they're already rate basing an awful lot of infrastructure, baseload generation, transmission assets. And if you look at it from the system's benefit, these things could potentially be rate-based as well. Many of the benefits that accrue from combined heat and power actually accrue to the system. They're somewhat universal benefits. We tend to think in terms of the benefit for the local facility where it's sited, but there are actually a lot of additional benefits. And I'll speak about those later on in this report. So the challenge, or the big issue with CHP, is that we all know how wonderful it is. It's a very efficient technology. It makes electricity or uses energy more efficiently than just about any other generation technology out there, but it has a lot of costs and risks associated with it, and they just don't line up. They don't line up well at all, at least in a traditional sense. And so what I've done in this slide is I've kind of color-coded. Red would be those benefits that would accrue to the host of a facility, blue to the utility, and purple for both. And I mean, obviously, if a factory or institution like the medical center that Deb mentioned would be interested in this, they want lower cost electricity. They want lower cost thermal energy. Maybe they want energy security. So those are very good benefits and desirable benefits. And in exchange for that, they would have considerable construction costs. They would have considerable operation costs, some of which they would have little control over, like the cost of natural gas or the market price of electricity. The utility has an equal mixed bag there, and if they are not the owner of that, they would have to worry about the same issues, but they like the stability of the price of natural gas, but they would also be concerned about the long-term viability of that host and whether the host would still need the thermal energy that comes out of that facility, let's say 5, 10 years down the road. And they may not even know what their own needs are going to be 10, 20 years down the road. So there's a mixed bag of benefits and risks, and they don't always line up. And I think in a fundamental way, this is why we have not seen more investment in CHP. There just hasn't been good alignment of risks and rewards. But I think utility ownership of that does answer many of those questions. So we'll look at first the benefits to, let's say, a natural gas utility and then an electric utility, presumably a utility that is both electric and natural gas could realize both of these. And I suspect it's kind of at an intuitive level, you would think that a combined utility would probably be more interested in this than maybe just one that served electricity or gas. But I think all three. I think there's justification for all three models to work. So going to a gas utility, it takes a big pipe to give natural gas to a cogen unit if it's going to have any size. And so the fact that that's going to be a reliable customer, probably operating in base load or near base load capacity, means that there's going to be a lot of revenue associated with the gas going through that pipe. And so they can leverage that for nearby customers, maybe an existing industrial park that needs more capacity, or a new industrial park that you don't have your anchor customers in there yet. So the cogen unit could be that anchor customer. And oh, by the way, you've got a thermal load that maybe some of those customers could use as well. So there's an awful lot of risk mitigation and leveraging that comes about for a gas utility with regard to a sizable cogen within their network. It also might be a way to attract additional customers, as I mentioned, in the industrial park, and retain those that you already have. Many of these same are true for an electric utility, but let's think about it from serving their other customers. They've got a low-cost resource. They can get electricity out of a cogen unit cheaper than they could from, let's say, conventional system, because it's a lower heat rate. I mean, from the standpoint of any utility, they look at how efficient that unit is at producing electricity, energy in, energy out, and it has a lower heat rate, so it's more efficient. The infrastructure costs could conceivably be lower. If you think about, let's say, 10 20 megawatt units versus one 200 megawatt unit, you might see some efficiencies of initial investment for that one big unit as opposed to several smaller units. However, the permitting cycle is longer. Everybody's going to have an opinion on it. And you're going to have more transmission infrastructure, possibly more substation, those types of expenses. So it could be a mixed bag. There's no guarantee that it would be lower infrastructure cost from the beginning. It could be at the long term. But I think having a more distributed generation profile probably is going to lean towards lower transmission and substation costs down the road. And then there's system reliability, resiliency. I'll get into that in a bit as an environmental compliance pathway. And there's several different ways that can be helpful. And then as opposed to just selling electricity, you've got a lot of different things you could be selling from a cogen unit, and thermal being just one of those secondary revenue sources. So I want to make sure my slide, there we go. Here's an example of how inexpensive CHP can be to a utility in search of energy efficiency resources. In Massachusetts, they have a specific program within their Mass Save portfolio that targets just CHP. And as you can see, of those three, it is almost, or actually half, less than half of what their other commercial and industrial energy efficiency programs are costing them on a total fully weighted kilowatt hour cost. In Maryland, they've got a CHP program, and they're looking at less than ½ cent per kilowatt hour. So now in these programs, I should mention that the utilities are not bearing the full cost of those CHP assets. It's the full cost of their incentives for those assets. But I just wanted to point out that there's some benefit there. Here's another chart showing the kind of all-in cost per kilowatt hour, or megawatt hour in this case, for different technologies. And at the bottom you can see 3 different options for CHP and see how they compare against other technology, more conventional technologies like gas turbines, coal, baseload coal, combined cycle, that type of thing. So I think that if you were to look at the cost of a simple combustion turbine versus a cogen with a heat recovery unit, certainly the second's going to be more expensive on the front end. But if you look at it maybe compared to a combined cycle, where maybe your efficiencies are starting to approximate each other, the difference isn't so much. So I think that the infrastructure costs are going to be very competitive in that regard. And because it's distributed, I think we're going to see that you can defer an awful lot of upgrades to transmission, or maybe the wires that you're hanging aren't as big because you've got a more distributed generation profile. And we're going to see an awful lot of new wires being strung. A good chunk of the transmission system is quite old. 70% of it's at least 25 years old. But FERC has given utilities the ability to spread some of these transmission costs out. I think this has much to do with the regional planning that's going on, the realization that our transmission system is not unlike the interstate system, and that states ought to be talking more with each other and thinking a lot about how they connect up with each other and organize their long-term plans. But another thing that benefits, how the system benefits from distributed generation, and of course CHP can be a form of distributed generation, is it reduces line losses at peak. We traditionally think of line losses as being around 7%, but that would be under normal operating conditions. When you start reaching the capacity of a transmission system, your losses, what an electrician would call an I2R loss or friction loss, increases exponentially. So it could increase to 3 times that 7%. And in one summer peak season up in Ontario, they found that, yeah, they were only spending $57 at the margins and generated an extra megawatt hour of energy, but to get it delivered, they were losing $115. So that their marginal pricing for peak power was off. And so if you move the generation around your system more, you can lower those line losses. Another thing that happens when you push the systems, the transformers fail. And I think that we've all seen instances of that around the country. A CHP system can provide a lot of ancillary services, which we'll talk about in a bit. And of course, they can support alternative fuels. They can either use different things like biomass and whatnot, or they can offset the intermittence of renewable energy technologies, such as solar and wind. And resiliency, I think, goes hand in hand with reliability. We certainly saw in the recent storms like Hurricane Sandy, or Superstorm Sandy and Hurricane Katrina, that those facilities that had cogens tended to stay operating when the grid went down, as opposed to those with backup power. An awful lot of the backup power didn't come up. And I think it's just one of those natures. It's kind of like Murphy's Law, that when you really need something, that's when it's going to break on you. And for all the efforts people made to make sure that their backup generators were properly serviced and everything, they just didn't come online as they should have. And so I think that one of the takeaways many people had from that is distributed generation. The natural gas grid did not go down. The electric grid went down. So if they'd had cogen, they could have used it. And that translated into a public safety issue. It translated into an economic issue. So there's an awful lot of things that come out of that. So I also want to talk about environmental compliance. CHP, by virtue of the fact that it is more efficient, it can be up to 80% efficient at turning fuel into useful energy, that it could be a form of compliance. And there's an awful lot of opportunities coming about as our existing infrastructure ages. I'm always intrigued that, it strikes me that the average power plant out there is as old as I am, and some of them are older, and these are getting ready for retire. These old coal plants are getting ready to retire. And if they're not being used in base load fashion, it's just not cost competitive to put the new pollution controls on them. And forget about carbon issues. You know, it's an issue of NOx and SOx and things like that. So I think that even though they get a lot of bad press, the environmental regulations get a lot of bad press about shutting these facilities down, many utilities are just shutting them down because natural gas is more cost competitive. It seems like the price is stabilizing, the technology is more efficient, it's easier to dispatch, the operating costs in terms of labor, maintenance are lower. So there's an awful lot of reasons to move from coal to natural gas. So we did a report in partnership with ICF International a couple years ago, and I think that they've done a great deal of work in this space identifying where those retirements are likely to happen. And we did a report out last year that Anna Chittum did identifying within a dozen states the opportunities to replace some of that retirement with CHP. And I will have the link for that report later on in this PowerPoint. But because CHP is more efficient, it is eligible, according to EPA, to use in state implementation plans for NOx requirements. And states can have set-asides specifically for CHP if they want to do this. And it's interesting that this has been in place since 2000, but many states, because of budget cuts to their departments of environmental management, have not had the staff to rewrite their rules. So they're still operating under the old rules that don't allow them to do this. But if you can work with your state environmental office, they can change the implementation plan to allow this opportunity. We are also looking at the potential that CHP will be an eligible technology for the upcoming Clean Air Act rules on power plant emissions for greenhouse gas emissions. And many industrial boilers that are now facing the Boiler Act rule on hazardous air pollutants are thinking that they need to change their boilers over to natural gas. Well, on a fuel cost, that's going to be more expensive than coal. But if they were to switch to a natural gas fired CHP system and use that to replace both their to replace their boiler and start supplying energy into their system, that would probably be a net positive for them on operating costs. So again, there's a lot of opportunities there to mitigate environmental costs with CHP. I mentioned that there are multiple products, or there's multiple products coming out of one facility. We tend to think of just the thermal load and the electricity in terms of kilowatt hours. And the thermal obviously could be steam, it could be hot water, but people often forget you can also do chilling. You can use the steam for chilling. And on the electric side, you've got not just kilowatt hours, but you've got kW. And you can do load following services for the utility. You can do spinning reserve and non-spinning reserve. You can do volt-var control, or essentially frequency control. So there's a lot of different products out there that make this a better mousetrap. If you gave me a choice between a power plant that had 1 or 2 revenue streams and a power plant with, let's say, 10 revenue streams, I think I might want the power plant that gives me 10 revenue streams. And that's how it tends to work in the private sector. The more products you have, the more stable your business. So we're seeing CHP deployed more and more. Dub mentioned how successful Texas has been in this, and we certainly see an awful lot throughout the Midwest. Much of this is at established industrial facilities, but I think there's considerably more opportunities to be done. I think that what utilities can do to encourage this is recognize that CHP is like transmission and regular generation. It is something that they want to do and should build into their planning. When they're putting together their planning, it should be just one of those things that they come together. I know they tend to think in terms of 100 megawatt units. In terms of generation, they're going to have to start thinking more in terms of 10 megawatt units and smaller blocks, if you will, to build up their long-term planning. And they should conduct feasibility analyses to back this up. Once they have that done, they should also do pilot projects, and they should experiment with how that works. You'll see how dispatchable it is, and they should measure all the different benefits that accrue from that. There are a lot of developers out there, some better than others, at putting in CHP systems, and so what they would want to do is start screening them, possibly giving their approval, if you will, to the degree that they can, so that industrial, commercial, institutional facilities that were looking to work with somebody might have that process a little thinned out. And then, of course, identify where you want those facilities on your grid. Again, as I started out, they know their grid, they know their customers, they know where it's going to make the most sense to have that. The regulatory agencies need to identify ways in which CHP energy savings can be recognized, and that would be all the benefits that they accrue to the system. And there's an awful lot of different ways to do this. We've written on it, and we can certainly be a technical resource for that. They also should start, the PUCs and the Departments of Environmental Management ought to talk to each other about how they can merge these two needs that they have. And then they need to give equal billing to CHP as a resource in their plans. And where they find barriers, work to remove those. Each state is very different in how it treats distributed generation, and there's certainly quite a few technical and financial barriers out there. And recognize that project times within energy efficiency programs, which are usually kept at a year, probably need to be longer for CHP projects. They're just not going to wrap up that quickly, and the performance of them is going to be over the long term. I'll mention that a lot of this presentation is based on a recent report that Anna Chittum and Kate Farley did for us. It came out earlier this year, as well as some of the work that has been done in prior years. And the links for those may show up here in a second. There it is. You will all get a copy of this, is my understanding, so no need to write down these rather lengthy blog or HTMLs, but certainly appreciate the opportunity to speak to you today and to talk about this, and I look forward to getting your questions at the end of this. And I'll turn it over to Julia.
Thanks, Ethan. I'm actually going to kick it to Dub to introduce the next speakers, but I will take this opportunity to remind folks to send in any questions that you have, and we'll be addressing them at the end. Thanks very much, Ethan.
You're welcome.
Great. Thank you, Ethan. Thanks, Julia. As we transition into the next slides, our next two presenters are both with Philadelphia Gas Works, which is the nation's largest municipally owned gas utility. The two speakers we have, Sharif Youssef, who's the Director of Sales, Marketing, and Corporate Communications for Philadelphia Gas Works. He is currently, let's see, his position, sorry about that, involves the facilitation and implementation of cost-effective energy solutions for large commercial and industrial customers. He's a mechanical engineer who holds a certified energy manager and professional engineer's license in the states of Pennsylvania and Delaware. Also has an MBA from LaSalle University. And then our other speaker, our second speaker from Philadelphia Gas Works is John Zook, the Vice President of Sales and Marketing. In that position, John is responsible for the direction of all of the marketing, sales efforts, and new business development for Philadelphia Gas Works. John holds a BA and a master's in business administration from LaSalle University and received his certified energy manager certification from AEE in 2004. He also serves on the board of directors for the American Public Gas Association Research Foundation and served on the board of the Greater Philadelphia Association of Energy Engineers from 2003 to 2007. So it looks like we have the slides teed up, and I will turn it over to you, gentlemen. Thank you very much.
Thank you, Bob, and thank you, Julia. First, I'd like to say that Ethan, on his presentation, he was really on a high level talking about combined heat and power. So while he was on a macro level, I'll be more on the micro level, and we'll be talking on small projects just to prove that as a large project was successful, small project can be as well very successful. PGW recognized the value of combined heat and power and lead by example by installing a combined heat and power system in the headquarters building.
1 second.
1 second. We are trying to take control here.
We're just trying to advance the slides.
Yes, I think we have a small technical problem.
Monica, I can bring up this. We're good.
Okay.
We got it. Great.
So in today's agenda, we are going to talk about the CHP system for the headquarters, as well as the Four Seasons Hotel. We are going to talk about the benefits of CHP, as well as the incentive program offered by Philadelphia Gas Works, some of the challenges, success stories, and why CHP makes sense. Our CHP system has three major components. The picture you see on the right side here, it shows the microturbine and the heat recovery system. The three components are microturbine, a heat exchanger. The heat exchanger is a small box to the right side of the microturbine, where you can see the big stack coming out of it. And finally, the absorber, and the absorber is inside the plant. You cannot see it. We have here a 200 kilowatt microturbine, very quiet unit. The noise very similar to a small vacuum cleaner. It displays around 50% of the electric demand of the building. The unit is running on what you call magnetic air bearing. It's very quiet drive. Normally, magnetic air bearing, it's the shaft is running more on air as instead of oil. Just a small comparison, when you drive your car, the RPM normally shows on your car between 2,000 and 3,000 RPM. If you cross the 4,000 RPM, you should really watch that there is no police car behind you. Well, the microturbine runs around 70,000 RPM. That is roughly 30 times the speed of your car, very similar to driving your car around 1,000 miles an hour. And because there is no oil and there is no lubrication between the shaft, it's very friendly for the environment, and again, there is no noise. The second small box you see is the heat exchanger, and the heat exchanger, it just takes the heat, which is generated from the microturbine between 400 and 600 degrees Fahrenheit, and it uses the heat for heating during the cold season, and during the hot season, and during the cold season, we put the heat through an absorber, and that will be our third part. Again, absorber, for someone who doesn't know what's an absorber, it's the magic box where heat enters in one side and cooling from the other side. Again, absorber is very friendly to the environment. There is no freon. The refrigerant is lithium bromide, which is mainly salt and water. So everything you see on this picture is environmentally friendly. Emission is almost non-existent, and everything is great for the ozone. When we started, we had a case study. It shows that a CHP system makes sense. While after we finished, while the estimated annual saving is $130,000, we have a plan to move our data centers into and connect it to our building, and that definitely will double the annual savings. The payback of the project is around 3.6 years. Life cycle saving is $2.5 million over 20 years. When we started our project, and again, this is an advice for any commercial or industrial entity looking for CHP, first thing they should look around for any grant, any rebate, any incentive. Could be from the state, from the federal, from sometime local utilities. And when we started the project, we got around $500,000 from the DEP as an award, which helped a lot on reducing the capital cost. One of the reasons we got this award was the justification of the project, where we mentioned that the project will be a showcase, and we're going to use the project to educate future students of Drexel, Temple, Villanova, all those engineering schools. When you prepare their students from the first year and you educate them about combined heat and power, you will have a second generation ready to design and complete and promote CHP. And just for that, or at least that was a good reason to get around $500,000 award. The next project, it's a little bit different than ours. Here there is only the two components, the microturbine and the heat recovery system. The project is a four-season hotel. When you deal with an hotel at the Four Seasons, it's everything should be the perfection itself. You have to be very careful about noise level. You have to be very careful during construction not to disturb the customers. So it required a lot of organization, a lot of meeting between contractors, engineers, customers, facility personnel. The original design, which was completed, and it took quite some time to complete this design because of the sophistication of the site itself, was for 5 units, each one 65 kilowatt. We completed phase 1. It has been running for almost 3 years now with 3 units at 65 kilowatt. And phase 2 after that will be 2 more units, again 65 each. The heat recovery out of that is used for laundry, kitchen, heating, and the next slide is the most important slide. If you are a commercial entity looking for a CHP project, you should really ask your question, this type of questions. How can I use this heat recovery effectively? And those are some of the thought you need to share with your designer or with your engineer. And the question is, well, what if the hotel is not fully occupied? What am I going to use the heat recovery for? What if I get a mild weather and I don't need that type of heat for heating? What if? And when you look for this sketch here, you will find that it's like a loop. And you start with the heating, and when the heating is satisfied, you go for domestic hot water. If you satisfy your domestic hot water application, you go for the kitchen, you go for the laundry, and you keep on. And when you get to the point where all your energy and heat recovery coming out of the turbine or your CHP system is used effectively, this is where you will be maximizing your savings. We did here everything to be sure that in case if we don't have full occupancy, if the kitchen is not on full load, if the laundry is not fully loaded, we always have an application for heat recovery. And that made the project very successful and reduced the payback and made it much better than what was originally designed. The installation for that project was less than 6 months, and everything from start to end took few months, and actually there was some delay because of the manufacturer of the heat exchanger. Other than that, we were really amazed. I was amazed by how fast the construction and completion of the project took place. Again, when we started the project, we worked hand in hand with the Four Seasons. Our strategy was always under promise, over deliver. So the economic analysis indicate at the first round a 5 years payback. The facility right now is currently on target to achieve this goal. However, the project right now is below 4 years payback. So customer is happy, the savings is there, and everybody's happy. Some of the benefits of having the small system like the small microturbine, it's having a modular system. You don't need to run all the turbines at the same time. If for whatever reason you get a mild weather, you can reduce from 3 turbines to 2 turbines to 1 turbine. And for that specific project, the turbines replace 30% of the electric demand and 15% of the heating. Again, if you go next to those turbines, you will hardly know that they are running. Not to mention other benefits which were very important as well for an hotel like the Four Seasons, which is the reduction of carbon footprint and the emission rate. That by itself meant a lot for them. Talking about other environmental benefits, using less fuel, reducing NOx, you have a separate system which pollute less than what the electric company or the gas company using it would generate. So we believe it's a win-win for the customer as well as for the utility. From there, I'm going to move my presentation to my colleague, John Zaw, and he will start talking about our incentive program.
Good afternoon. Thank you. One of the things Ethan mentioned earlier about barriers to try to get CHP into facilities. Well, one of the major problems, one of the major barriers we found here in the Philadelphia area, and actually in the Philadelphia, we are from the Philadelphia Gas Works, so our territory is the city of Philadelphia only. We can only extend outside. So one of the barriers, and one of the major barriers, was incentive money, capital money. A lot of times customers would come to us and say, we don't have the money, we don't want to put it on our books, we don't want to put any capital on our books. So being a municipally owned utility, we had to figure out a way to try to provide some incentive, but also get paid back that incentive. So what we've done is we set up a program where we will provide the money for upfront costs, capital costs, but not put it on their books. And how they reimburse us is through operating. So for a quick example, is if we were to incentivize a project by $1 million, and that project was going to provide about 100,000 decks a year, that ends up being in a 5-year payback, $2 per deck. And that's how we would get back the money. Now, in addition to that, which I didn't mention earlier, we have cost of the money. Like I said, we don't have as stockholders, everything goes back to our ratepayers. So we right now are currently borrowing, or recently borrowing at 5%. So we get that back with our money. So that's included in the numbers that we get back, the money that we charge the customer. So usually, if per deck, if for the transportation charge is about 50 cents, we'd add $2 of that, so it'd be $2.50 for a 5-year payback. And like I said, a lot of our customers are actually very excited about that. And even the ones that wanted to take advantage of it, as the project moved along before its start date, they would get back to us and say, you know what, we don't need your money, we can borrow it cheaper, so thank you very much. but it was a barrier in the beginning that we tried to get over, and a lot of times we do that now. So we usually get to the next, second, or third step. One of the things I'm going to talk about real quick is the stability of natural gas going forward. I had a different slide on this earlier, but just to explain what the other slide was showing was, it showed here. The peaks going up to $13, $14 in 05, 06, and also in 08. With the abundance of natural gas going forward, if you look at the Henry Hub prices going out to even 2020, you're looking at gas on Henry Hub being anywhere from $4.50 to $5 to $5.50 at the max. So, which is fantastic for the gas industry, and like I said, it helps to reduce your operating costs at whatever facility you have. Again, some of the other challenges that I said Ian has spoken about, but I'll just mention them briefly. Decision makers and resistance to change. That's one of the bigger ones too, because of the fact that people like what they're doing, and if somebody was at their facility for a long period of time, and one of the things we find that they're looking to retire in the next 2 to 3 years, they don't want to get into a larger project. So we needed to find somebody, whether it's that person or even a the financial guys from the companies, to say, listen, you're going to save money moving forward. You can see the savings in money the next 2 to 3 years or 5 years, but at the least amount, it'll take 5 years to pay us back, and you'll start seeing savings in 5 years. But as Sharif has set up several of our customers, we did it in a way where the customer would see savings immediately, so which helped projects along and which helped sell the projects to customers. Some of our success stories, as you can see here, PCOM, which is one of the universities in the area, has several commercial buildings. The Navy Yard has a fuel cell, which is Urban Outfitters, Independence Business Center. But on some of these projects, we sometimes have to increase the main and service to put in there, but half of them we don't. So, which is good for the customer, is they don't have to put any money out for infrastructure, and the only thing we need to do is increase the meter size. And with that, we can increase our pass-through from having 2,000 to 3,000 decks a year to now 12 to 13 to 14,000 some of these projects, without really having to do any infrastructure upgrades. The only thing that needs to be done is purchasing the equipment at the facility and them doing some work internally. Why it makes sense? Why CHP makes sense? Well, again, as I spoke briefly about the supply of gas. The supply of gas, the abundance of it, it's not just only in the state of Pennsylvania, but it's throughout the U.S. So it really makes sense to using basically a local product. You want to have better control over your facility and your operating costs. Okay, there's software out there that helps you can actually know when you need to turn your CHP on, or using it 24/7, or when you can shut it down and actually go off the grid. Either way you look at it, you control it now, not a third party. Good. So that's all I have. So I guess we can open it up, Julia, to any questions.
Great. Thanks so much, John and Sharif. We do have a couple of questions that have come in. And so for each of the speakers, we'll start with those. I'm just going to change. So the first question is for Ethan. And the question is, can CHP be used by state regulators developing SIPs for anything besides NOx, for example, PM 2.5, SO2, or ozone?
I believe they can. I'm trying to think if I actually know for sure the answer to this, and it's been a while since I've looked at the information, but would be happy to look into that and get back. But when I skimmed the information prior to today's webinar, I tended to focus on the carve-out that is mentioned for NOx.
Thanks. Yeah, I would also mention, so NASIO has been working with EPA's Combined Heat and Power Partnership, and they're supporting this webinar. And I believe that they're also working on a case study of using CHP for other SIP compliance. And so NASIO will certainly circulate that to our members once it's ready.
Okay.
The next question is for John and Sharif, and it came in during your presentation, and it's asking, was the existing gas line enough to feed to the turbine and generate the electricity, or did you need to layer an extra line? Oh, there are a number of questions embedded in this, so hold.
Actually, yeah, I can answer them.
Okay.
Yes, the line was large enough to, when they installed the CHP unit, that the line was already large enough to handle that. So we didn't have to do any work to the line, to the main, or the service. The only thing we had to upgrade was the actual meter. And when we upgrade our meter, we don't, it's our meter, so we don't charge that to the customer.
Okay, great. The second part of this question is, does the facility need to do rate contracts for consistent supply of gas?
They have, with their supplier, when it goes to an IT, interruptible transportation, what happens is they get a contract with their supplier, and they work with their supplier to determine how much gas they're going to need per month through the year, and they do balancing. They say the bundle balancing with other customers. So to answer the question, I think I answered it, but what I'm saying is they need to have a projection of what they're going to be using, and they notify the supplier. If the machine goes down for any reason, they need to notify our supplier so they can, so the supplier can not nominate for that day.
Great. Okay. Thanks. And then the third part of this question is, if for some reason natural gas is no longer available or becomes costlier, is there any other fuel source which can run the turbine and generate the electricity with the existing setup?
Now, with the existing setup, what we do, we leave everything the way it is. So they will have the PECO as their electric company supplier. Their system will be there. All we do is just we add one more system which is more economic. So for whatever reason, if the turbine is down, or if there is interruption, or if natural gas is not available, then they can go back to PECO and use their normal electricity.
Great. I think the next set of questions is also for you guys. For the projects that PGW are marketing to customers, who deals with the electricity or the electric utility and the hookup to their grid?
Normally we have one mechanical contractor, and the mechanical contractor will have his licensed electrician, and he has to go and get all the permit and to satisfy the code as well as the electric company. So the contractor normally handle all of that. We will be the one supervising that everything is installed by code and by tariff.
Great, thanks. I think the next question I'll open up to John, Sharif, or Ethan, anyone who wants to jump in. So under a typical electric utility ownership model, how might the contract look specifically with the utility rate base, the investment, and sell the manufacturer institution thermal energy from the CHP at a reduced cost, or would there contract with the consumer for both the power and the heat?
Yeah, Ethan here. I think that it could be any one of a number of ways, but let's say that you had a fairly large facility. The utility identified a need to put in, let's say, a 20 megawatt unit at a certain location in the grid, and they came to the facility that was there. Let's say it's an industrial facility, so they would build the asset. They might have to pay rent on the property, but they would, let's say, build the asset, own the asset, and they would pump electricity into their grid, and they would probably sell electricity to that industrial facility at whatever the normal rate would be for that level of transmission for that level of customer. Then they would have the secondary business of selling them thermal, and so they could sell thermal into that facility. in terms of pounds of steam or whatever that mechanism would be. They would probably have an obligation to buy over a certain amount of period. So the facility would, I'm sure they would want to negotiate a pretty good price on that thermal load to make it worth their while, but they would probably have to trade off for that an obligation to buy. I suppose there's no reason why they couldn't have a special rate on electricity, but the utility might not, from their perspective, it's just a power plant next door to you. There's no necessary advantage there, whereas there is on the thermal side. And the utility would realize all the benefits of the ancillary services, and they would operate the system pretty much like any distributable, dispatchable asset. So that's kind of one model that I think would be appealing to utilities. And that they would just go before the PUC and say, we want to build this, let's see, if it's 20 megawatts, it's probably going to be about a $30 million operation, 30, 40 million plus or minus some real money. And they would build that into the rate base. At least, I'm not sure if they'd be able to build all of it into the rate base, but I'm sure they could ask.
Thanks very much. And then I guess that kind of leads into another question. You mentioned that the importance of states recognizing the system benefits of CHP in order to allow utilities to invest in them in these systems. Do you have examples of states that do this?
I don't believe that we have seen this yet outside of in Southern Territory. I think Alabama Power has a couple of assets that it owns that are on large industrial, probably paper mill properties.
Okay. And then Ethan, can you, so the question is, are there case studies available of electric utility-owned CHP projects? Dub mentioned Austin Energy earlier as an example, which I think you guys talk about in your paper. Can you just recite kind of where folks can find the papers that you published again?
Yeah, certainly. You can go to our website, which is acee.org, and under the header for research papers, you can search for any one of our papers. And if you just type in CHP for any given year, you'll get several different ones. The paper that this was based on, that my presentation today was based on, was called Utilities and the CHP Value Proposition. But there are other reports. There's one called Coal Retirements and the CHP Investment Opportunity, and that came out in 2012. And there is another report called Follow the Leaders that came out in 2011. And all three of these were, the lead author was Anna Chittum, and so you can search under her name too. But probably one of the best parts of our website is the ability to search all of our literature. It's all downloadable, it's all free, and if you want to use any of it in any presentation, you just let us know that you want to do that, and it's not a problem.
Great, and we can send around the references and citations for all of those papers in a follow-up email. Last question for Sharif and John. Were local zoning and permitting requirements an issue at all in any of your projects?
The first project we had some challenges because as John mentioned, we are the gas company, and the electric company, they wanted to protect their assets. They wanted to be sure that electricity will not go back to their system in case of some malfunction or interruption. So there was some minor issues at the beginning, but After the first project, we knew exactly what they were looking for. We knew exactly how to satisfy all the codes and CT requirements, and after that, everything was moving smoothly.
Great. Well, thank you very much, John, Sharif, and Ethan, and Dub, for all of your remarks today. I think that this is a great webinar and a great set of presentations. One last reminder to everyone, we will be sending around links to where the presentation can be found, both the recording and the slides. And so thanks very much for your time today, and that will conclude our webinar.
Thank you.
Thank you.
Thank you.